Take that, cow! Hi, Jake from Real Robots here. So I've been planning on making this Minecraft pickaxe game controller for quite a while now, and this is the final version, I think. I did do a test run before this made of just cardboard, which worked pretty well actually. None of that on video, unfortunately. I'm actually coming to this after about a year of leaving it sitting on a shelf, and I can't actually find which shelf I left it on. In any case, the cardboard version, although it looked good to start off with, it didn't handle itself too well after a few whacks. It started to look a bit worse for the wear pretty quickly. So I finally settled on this cosplay foam, which is some really neat stuff, and the good thing is there's a lot of videos out there teaching you how to use it well. I did not use it well, but it's great. I've got it in this 5mm thickness, which means I can make my standard Minecraft cube size 2 centimeters. So it's going to be 2 centimeter grid drawn out on this, and that means I'm going to have 4 layers, which gives me 2 outer layers and then 2 inner layers, which I can cut up however I like and squeeze some electronics in there. Now you may notice that my foam switched color at this point and suddenly got cut much more accurately. That's because at this point I realized I had access to a laser cutter and I was really bad at cutting stuff, and so I went away and laser cut the rest of it. Hand cut one did work fine, you can do that, but I've got a laser cutter, so I'm going to use the laser cutter. And it's now black because I did buy black and white, and I used to use the white originally because I need to be able to draw on it and see it, but the laser does not need to see where it's going. Another cool thing about the darker foam is that it seemed to absorb the laser a lot better and cut a lot more cleanly and quickly. So that's good. So after I had my 4 pieces ready, I glued them together in 2 Oreos like this. And then after giving it about 15-20 minutes just to dry a little bit so the glue would hold it in place, I grabbed the electronics. So nothing too groundbreaking here. For a microcontroller, I've grabbed the Arduino Pro Micro. Now I picked this one because the microcontroller on this guy is the Atmega 32U4. This has a bit of a benefit over the normal Arduino Uno microcontroller in that it does USB HID out of the box. And what that means is that with some really simple software written on this, we can plug it straight into the USB on your computer, or any device that will accept USB pretty much, and it'll tell that device that it's a mouse or a keyboard or a gamepad or a joystick, and send key presses, clicks, axis movements, whatever you like. I've also got this little PSP style thumbstick, 2 little push buttons, and this one is an ADXL345 3-axis accelerometer. And this is going to give us our tilt sensing. So I'm just laying out the electronics where I think they're going to go here. Grabbing that original cut piece and just feeling it in my hand, working out where I want the buttons to be. Now I'm happy with the positions. I'm going to cut some slices out of this middle layer of foam, big enough to fit the electronics where I want them to be. This is why it comes in handy that the glue hasn't dried all the way through yet. It's dry enough to keep my foam layers from sliding around, but not so dry that I can't get the pieces out. And now just cutting a trench for the wires to run all the way through, down to the microcontroller at the base. Now it's time to wire everything up. There's nothing too complicated here, but there's a lot of wires, so it is a bit tedious. First I put the Pro Micro and the accelerometer in their places and measured out a bit of wire. Now the accelerometer needs 4 wires, needs its 5 volts positive, its ground, and also 2 wires for communication. It's a I2C device, so they're going to go to the pins 2 and 3 on the Arduino Pro Micro. And once those 4 are connected, I just twist them together gently, not too much, just to keep them neat, and also just so they can rely on each other for strength a bit more, as the soldering is always going to be a little bit brittle, especially with these thin wires, and we don't want anything to come loose. Next comes the 2 push buttons. Now these guys are pretty simple, just 2 wires each. one for ground and one to go to one of the digital pins on the Arduino. We're using the built-in pull-up, so we don't need to add any extra pull-down or pull-up resistors here, which is very handy because I'm already getting tired of soldering stuff. Now, if you look really closely here, you'll see this is where I actually screwed up. I cut some of the wires a bit too short, and rather than cut new ones that are a bit longer, I decided to be lazy and just move the Arduino a little bit further up. So this is a standard 2-pot thumbstick, so it needs its 5-volt source, ground, and one output pin each for the X and Y axes. Starting to get a little bit crowded here. So these guys plug into, of course, the 5-volt VCC and one of the 3 ground pads, and the 2 analog outputs for X and Y axes will go to my analog 0 and analog 1 pads. Now that everything's connected, the next step is to glue it all permanently, but before we go that drastic, I need to make sure everything works. So I'm just going to run this little Arduino script I've written, and it's just going to send me the readings from everything, and I can make sure all the connections are good. Now, astute viewers may notice that the numbers don't actually match up to what I'm pressing here. I recorded a few videos of this before I got one I was happy with, and then I couldn't work out which one went with what. Good news is it did work, even if this wasn't actually the video of me finding that out. All the connections are good, so time to start gluing. A touch of glue under each component first to hold it in position. Just tuck the wires away in there too, so they're nice and comfy and out of the way. And then do one more quick test before absolutely slathering everything in hot glue. We're going to be waving this thing around our heads and everywhere and probably dropping it and hitting it on things. Need to make sure these guys are not going to come loose. So when that hot glue's cooled, gently tug it. Yep. Unplug it. Make sure everything's in there nice and tight. Yep, nothing's falling out. Beautiful. And now time for the second half of this sandwich. Now, most of the wires and components all fit in that one half, but we need to cut a bit of extra space on this side for the switches because they protrude a little bit, and also cut a little slot out for that thumbstick. And look at that, absolutely perfect. Then we slather a goodly amount of this white glue. This is just normal PVA glue, by the way. I just went down to the hardware store and bought the cheapest one I could find. We spread that all around there. Press them together firmly. And then I'm going to take this away and put something heavy on it to squish it together overnight. Now begins the long and exciting process of painting. Now this foam is basically like a sponge, so I'm going to have to put something over it before I start painting it, or else I'm going to be putting layers of paint on all day. I'm going to put probably 2 or 3 layers of this PVA glue over there. I've heard it's not the best stuff for sealing the foam, but it's what I've got. I'm also hoping it's going to do a decent job of just stiffening the foam a little bit and making it a bit more robust and less floppy, I guess. Okay, the real reason I recorded all the painting was just so I could get this beautiful shot of paint drying. Lovely. So then I painted some squares, and then painted some more squares. Then some more squares, and more squares, and then some more squares. And then I painted some squares. Oh, then I painted some squares. This is me painting long rectangular squares. Getting pretty near the finish line now. And then before I knew it, the painting was finished. If you look real close, the paint job is a bit rough, but there's no way I'm doing that again. So then I wrote some firmware for the microcontroller. And then I wrote this little tool for remapping the controls. I was pretty happy with this. I found pretty quickly that changing the controls was a big pain in the bum when I had to re-upload the code to the Arduino every time. So I made this guy, and it just sends a little serial packet which tells it what every control should be. It's just 11 buttons, so 11 little numbers, and the Arduino converts it. So when you plug yourself in and connect, it'll grab the current controls that are installed right now, then you send out the new ones. And then the pickaxe will store the current controls on its EEPROM, and so it remembers it even after you turn it off and on again. So this turned out a lot better than what I expected. It's a bit more of a joy to play. It's not as nice as playing with a mouse and keyboard, obviously, but it's pretty fun. I'm not sure if I mentioned it earlier. What I've got is I've got the two buttons. I've got the thumbstick with two axes there, and I've got the tilting left, right, forward, backwards as a third and fourth axes. But I've also programmed it so if you whip it forward really fast, that's a key press as well. And I've got that programmed for my mouse button at the moment. So yes, whacking back and forth is actually doing the Minecraft pickaxing is the word, I guess. So this is pretty fun, but I think it's time for something a bit more challenging. This doesn't use Minecraft controls. Might fiddle with this a bit. Alright, there we go. Yep, this is how we play Dark Souls 3 now. I'm gonna run the whole game with this thing. This doesn't feel too bad actually. Okay, once you get the hang of it. Yes! Champion! Alright, first guy killed. I think is there a couple more than that? Yeah, there's probably one or two more. Anyone hiding down here? Did I set a pickup button? Yes! Yeah, that's it. I can't believe this is working so well. I really feel like I play the whole game like this. Just to show, I'm only using one Minecraft controller at the moment. There's no single controller in my hand. That is how to do it, mate. I'm smashing these guys. Make sure he's dead. Check that. Yeah. Alright. On to glory. You hear that? This guy's standing right in front of me. Controller doesn't help me see. Yeah, take that. Alright. Oh, wrong way. This is the time I'm turning a bit as I try and do the swing hit. Because my movement controller is controlled by that accelerometer, but whipping it is what gives me the attack. it's hard to sort of attack without moving sort of left or right at the same time. Yes, I can't. Okay. Wow, I guess that was inevitable. So, that was a lot of fun to make. It got into a lot of stuff that I don't usually do, like the painting and making something look pretty. Usually I'm all about the functionality. And usually I'll get bored and move on to the next project before I get to anything like that. But I really love this so much, I'm thinking now, what other custom controller can I make? But that's all I really have for today. If you ever want to make something like this yourself, I've kept this all open source and put as many of the files down below as I could think of. If anyone has any questions, feel free to drop them in the comments below. Thanks for watching.